Alright, so in this video we will solve the partial differential equation given by 5 partial of u with respect t plus 11 partial of u with respect x equal to 0, where u of x 0 equals to 3 e to the 5x plus 5 e to the 7x plus 8 e to the 6x. And we're going to solve this partial differential equation using separation of variables. Now, before we separate the variables, we need to assume a solution of the form u of xt equals to some function of x times a function of t. In this case, we assume a solution as a product of these two functions, one of each independent variable. Right, so in this case, I'm going to take the necessary partial derivatives as required in the partial differential equation. So I'm going to take the partial of this u function with respect x, that is f prime g, and then the partial derivative of u with respect t, that is f g prime. The results of this are because differentiating with respect x, g, which is a function of t, is just a constant, so we just differentiate f. And when we differentiate u with respect t, so f, which is a function of x, remains constant, so we just differentiate g, which becomes g prime. Now, substitute this into the PDE for short, partial differential equation. Okay, that's going to give us 5 f g prime plus 11 f prime g. And let that be equal to 0. All right, to separate the variables, usually a good trick is to divide both sides by the product fg. Right, that's going to leave us with, okay, cancel, that's going to leave us with 5 g prime over g plus 11 f prime over f, and let that be equal to 0. All right, so we're going to separate the variables by keeping all the f's on the left hand side and the g's on the right hand side. Right, so 11f prime over f equals to negative 5g prime over g. Okay, and I'm going to isolate the f's, and that is by dividing both sides by 11, so that's going to leave us with f prime over f equals negative 5 over 11 g prime over g. And well, at this point, we just separated the variables. Again, to solve PDE using separation of variables, we need to introduce what we call a separation constant, and usually we call it k. All right, this is to solve essentially two equations. An equation for the variable x, which is usually what we call the spatial equation, because that's the space, that's the part of the solution that describes the space, and the temporal equation, that is the part of the solution that describes time. All right. Well, so separating the variables, we get one equation, f prime over f equals to k. And well, let's solve this equation. So this f in the denominator means really 1 over f, and I'm going to change the notation for f prime, and I'm going to write it as df dx, and let that be equal to k. So we're going to separate the variables for this differential equation. That's going to leave us with df over f equals to k dx. And at this point, we are ready to integrate both sides of this equation. So let's go ahead and do that. That's integral. So this will be ln of f equals to kx plus some constant of integration that I'm going to call c. Right, so we're going to exponentiate both sides to get f by itself and cancel e with ln, and f equals to e to the kx And again, e raised to a constant, that's simply that constant. So we just obtained the function f. Now let's do the same to let's do the same with the function with the equation for g, right? That is for the time equation or the temporal equation. That is negative 5 over 11 g prime over g equals to k, where in this case, well, I'm gonna multiply both sides by um, negative 11 fifths. At the same time, I'm gonna write 1 over g times dg, and in this case, since g is a function that depends on t, that's dg dt. That equals negative 11 over 5 k. All right. So separating the variables for this second equation, that's going to leave us with dg over g equals negative 11 over 5 k dt. Integrating both sides, again, we're going to get an ln of g equals to negative 11 over 5 kt plus, in this case, rather than using c, because we're solving a different equation, let's use a different letter. That is d. I'm going to use d. And again, let's exponentiate both sides. And that's going to leave us with g equals to e to the negative 11 over 5 kt, and e to the d is simply another g. All right, and we just obtained the two functions whose products are going to be the general solution to the PDE. Back to it, u of x t, that equals our f of x g of x equals to c e to the kx times d e to the negative 11 over 5 kt, right? And well, to express the solution in a more proper way, well, u of xc equals to, okay, here the constants c and d can be absorbed because these are just arbitrary constants. Just call it a times e to the kx minus 11 fifths k t. And actually, it would be great if we factor out the k, right? So that's what I'm going to do. U of xt equals to a e to the k times x minus 11 over 5 t, all right? And that is our general solution, right? That's our general solution. Now, we need to find the particular solution. In this case, that one given by the condition u of x0 e to the 3a to the 5x plus 5 e to the 7x plus 8 e to the 6x. Okay, so using or with u of x0 equals to 3 e to the 5x plus 5 e to the 7x plus 8 e to the 6x, right? Well, what are we going to do? We're going to substitute, we're going to evaluate this. U of x0 equals to whatever you, whatever that this means that wherever you see the letter t, the variable t, replace it with a 0. That is a e to the k x minus 11 over 5 times 0, okay, which is a e to the k times simply e to the kx, okay. Well, let me make some space. So, but the question here is, what's u over x? 0. Well, that's actually the result of what we have on the right-hand side of the condition, the initial condition. That is 3 e to the 5x plus 5 e to the 7x plus 8 e to the 6x. Now, the question here is, how do we solve this initial condition? How do we get a? Well, in this case, we're going to use again some sort of equating coefficients or like the method of undetermined coefficients. However, we only have one exponential term on the right-hand side and three on the right and three on the left-hand side. One way is to go one case at a time, which could be a little bit more writing. However, we could rewrite or redefine uh, this A, okay, that A which is just an arbitrary constant. Call it A plus B plus C. Three letters because we have three terms. That is, if you had, say, seven exponential terms in the condition, well, use a total of seven letters. So I'm going to rewrite A plus B plus C e to the kx, and let that be equal to the expression in the condition. And then, well, I'm going to distribute. Okay, I'm going to distribute. So 3e to the 5x plus 5e to the 7x plus 8e to the 6x equals to a e to the kx plus b e to the kx plus c e to the kx. Also, well, since we are finding different values of case, if you will, you might want to label this case as a case of 1, case of 1x, case of 2x, and case of 3x, because we have different exponential functions with different exponents, really. So with this, we can equate coefficients. So that means a, that is the coefficient of the first term, equal to 3, okay, and b equals to 5, and c equals to 8, right? So a equals 3, b equals 5, and c equals to 8. On the other hand, the case, the constant's case, let me use different colors for this. 5 equals to k1, 7 equals to k2, and 6 equals to k3. Okay, so k1 equals 5, case of 2 equals to 7, and case of 3 equals to 6. And now we have a case for the particular solution. So u of xt will be 3 e to the 5 times x minus 11 over 5t plus 5 e to the 7x plus 7 times x minus 11 over 5t plus 8 e to the 6 times x minus 11 over 5t. And well, you might want to distribute this to simplify and clean up parentheses. So u of xc equals to 3 e to the 5x minus 11t plus 5 e to the 7x minus 11t, rather 77 over 5t plus 8 e to the 6x minus 66 over 5t. And that is our final answer.